All right, welcome to day 2 of other equations. We're going to start today with something that we were working on yesterday, and that is we're going to use the idea of u substitution. So if I look at this example here, I have a quadratic. If you don't like the idea of having the negative exponents, well, one of the things that we can do is we can say, all right, u is equal to x to the negative 1. Remember, you're always going to do u equal to the middle one. All right, so x to the negative 1 squared would be x to the negative 2, which means that would be u squared. So now I got negative 63u squared. I've got plus 2u, and then plus 1 equals 0. All right, if I don't like having a negative 63, so I'm going to just go ahead and multiply everything by negative 1. I'm going to change this to 63u squared minus 2u minus 1 equal to 0. All right, that makes things a little bit easier. Reason is, if I can come up with two numbers that multiply to be 63 that are 2 apart, well then I can make that factoring a little bit easier. And I can come up with the idea that 9u, and I'm going to go plus 1, and 7u minus 1 equals 0. Notice that if I do the 9u times the negative 1, I get negative 9u, and 7u from the outside and inside terms combined to be negative 2u, and 9 times 7 is 63. All right, so now when I go to solve this, u is going to equal a negative 1/9, and u is going to equal a positive 1/7. Remember, it's always the opposite of the second number divided by the coefficient. All right, but at some point I have to change these. So u is the same thing as x to the negative 1. So that means that x to the negative 1 is equal to 1/9. But remember that x to the negative 1 is basically 1 over x is equal to, and I forgot the negative up here, negative 1/9. Which means that if I want x, if I just flip both sides, x is equal to negative 9. If I do the same thing for the other one, I've got x to the negative 1 is equal to a 1/7, which means that 1 over x is equal to a 1/7. Whoops, yep. And then I've got x is equal to 7. So that's how I can solve for x using the idea of u substitution. But like I said yesterday on the other video is that you don't have to use u substitution. So normally I would have you stop and try this one on your own, but I'll just show you how you can just do this without, and you just have to understand that since, negative 2 is half of negative 4, that we can just, change this to a x to the negative 2 and an x to the negative 2, and then equals 0. All right, and then all we really have to do is we just got to fill in. Two numbers that multiply to be 24 and add to be 10 would be a 6 and a 4. Two numbers that multiply to be a positive 1 would be a positive 1 and a positive 1. Okay, if you FOIL that out, you should get back what you started with. And now we can just do it without the u substitution. Okay, so x to the negative 2 is equal to a negative 1/6. X to the negative 2 is equal to a negative 1/4. Now remember that means that 1 over x squared is equal to a negative 1/6, and 1 over x squared is equal to a negative 1/4. Now, how is it possible that I can square something and get a negative number? Okay, well, that's not possible. So in both these cases, both of our answers end up being extraneous, and so therefore we have no solution. Okay. All right, but you could have, just FYI, if you like the idea of u substitution, you could have done u is equal to x to the negative 2, and then you could have done a 24u squared plus 10u plus 1 equals 0. And then just remember, you always have to go back and plug in the x equal to negative 2. All right, so now you've seen it both ways, and then from there, you get to decide which method that you would like to use. For example 3, you've got your options. So I'm going to show it both ways, okay? If you like the idea of u substitution, remember that u would equal the middle term, so u would equal to x to the 2/3 power. That would change this entire function into 9u squared minus 10u plus 1 equals 0. And then from there you can factor that to a 9u minus 1 and a u minus 1 equal to 0. And then when you go to do u is equal to a 1/9 and u is equal to a 1, you have to change the u now back to x to the 2/3 equal to 1/9 and x to the 2/3 equal to 1. Okay? Otherwise, you can just recognize that 2/3 is half of 4/3, and you can go directly to just factoring this to 9x to the 2/3 power minus 1 times x to the 2/3 power minus 1 equals 0. And then x to the 2/3 is equal to 1/9, and x to the 2/3 is equal to 1. All right, so in both cases, you end up in the same spot. So now what we just have to do is we have to get rid of this 2/3 power. And remember, all we have to do then is raise that to the 3/2 power. So if I raise that to the 3/2 power, 2/3 times 3/2, they just cancel out because they're going to equal 1. So now I'm left with x to the 1 power is equal to 1/9 to the 3/2 power. If you need to, remember we talked about how you can change that into the square root of 1/9 cubed. The numerator is your power, the denominator is your root. Well, if I do the square root first, now I've got x is equal to 1/9, or the square root of 1/9, which is 1/3. But remember, anytime I take the square root of both sides, I need plus or minus. And then I have to raise that to the 3rd power, giving me x is equal to plus or minus 1/27. Doing the same thing to the other side. If I raise both sides to the 3/2 power, then I end up with x is equal to 1, or 1 to the 3/2 power, or x is equal to, when I take the square root of 1, plus or minus 1 to the 3rd power, or x is equal to plus or minus 1. So there are 4 solutions here. Reason why there are 4 is, notice that our numerator on our original function had a 4, okay? All right, so I show both ways. You need to know one of them, and whichever one suits you best. All right, solving our square root functions. All right, this is similar to our absolute values, and what I mean by that is one of the things that you want to try and do, okay, is you want to think about isolating. So try and isolate the radical. Okay, and the reason why you want to do that is it just makes it easier, because then our goal then is going to be to then square both sides. And you're going to see on a couple of our examples how it can be a little bit more complicated, okay? All right, so right off the bat, you see in example 4 that the radical is already isolated, which means that I can go right ahead and I can just square both sides, and I can get 3x plus 4 is equal to 64. I can subtract 4 and get 3x is equal to 60, and then x is equal to 20. All right, so just remember with our equations, we should always plug our answers back in just to see that it works, especially with radicals, because remember, you can't take square roots of negative numbers. Absolute values always have to equal positives. So think about those situations. So in our case, the square root of 3 times 20, which is 60, plus 4 is 64, would be 8. If I took the square root of 64, I get 8. So it does work, okay? All right, and example 5. First thing I want to do is I want to isolate the radical, so I'm going to move this 10 over. So I've got the square root of 2 minus x is equal to x plus 10. Now that I have it isolated, I am going to square both sides. And this is what I meant by it gets a little bit more complicated, because we just have to FOIL this side. No big deal. All right, so I've got 2 minus x equal to x squared plus 20x plus 100 after foiling. Since I have an x squared, I want to make sure that I set equal to 0. So 0 is equal to x squared. Add the x over and I get 21x. And subtract the 2 over and I get 98. All right, just to help you out with the factoring, this does factor. Okay, it factors to an x plus 7 and an x plus 14. 7 and 14 add to be 21, and 7 times 14 multiplied to be 98. All right, so what that means is now x is equal to a negative 7, and x is equal to a negative 14. All right, so again, you just want to plug them back in, okay? So in the very first one, we would have the square root of 2 minus a negative 7, which is 9, okay? Minus 10 would have to equal negative 7. So the square root of 9 is 3 minus 10 equals negative 7. Check. Okay, if I plug it into the second one, the square root of 2 minus negative 14 minus 10 equals negative 14. So I got the square root of 16, which is 4 minus 10 is equal to negative 14. Does 4 minus 10 equal negative 14? No, so therefore this one does not work, but this one does work. Okay, so again, you always just want to make sure that you are just checking your answers to see if they work or not. Okay, so the negative 14 is extraneous. All right, last example. For this one, we have two radicals. So I talked about the idea that you want to isolate one of the radicals on both sides, okay, or isolate the radical on both sides. Well, in this case, we just have to choose one of them to isolate, and then the other one we're just going to have to leave as is. So because this says minus, I'm just going to move this to the other side. Does it matter which one I move? No, it doesn't. It's just that way both radicals are positive. That's the only reason why I chose that. Okay, so I'm left with now x minus 5 in my radical, and then plus the 1 is equal to now a positive square root of x plus 4. Now I have to go around the business of squaring both sides, which means I do have to FOIL this. I can't just distribute that square. Okay, I'll do the easy part here. This is simply x plus 4, done. And then this. So I have to do the square root of x minus 5 times the square root of x minus 5, which is simply just x minus 5. Then I have to do the square root of x minus 5 times 1 twice, which means that I have 2 sets of x minus 5. And then I got to do 1 times 1, which is 1. All right, from there, I just want to simplify. As you see, I have a radical still. So what I'm going to have to do is I'm going to have to isolate that radical, and then I'm going to have to square again. All right, so let's combine like terms. So I've got x minus 4 plus 2 root x minus 5 equal to x plus 4. As you can see, if I subtract the x to both sides, they are going to cancel out. I might as well add the 4 to both sides while I'm at it, giving me 2 square root x minus 5 is equal to 8. I'm going to divide both sides by 2, and I'm going to get the square root of x minus 5 is equal to 4. I'm now going to square both sides and get an x minus 5 is equal to 16. Add the 5 over, and x is equal to 21. All right, I should just check to see that that works. So I got the square root of, the square root of 21 minus 5 minus the square root of 21 plus 4 plus 1 equals 0. This is 16, so I got the square root of 16. This is 25. And plus 1 equals 0, so 4 minus 5 plus 1 equals 0, and it works out, so check. So this solution does work, okay? But again, just get always in that habit of checking your solutions. All right, hope that helps, and if you have any questions, please come with them in class. You know, the big thing that I talked about with my students was paying attention to details. Extraneous solutions is definitely one of those details that you have to pay attention to.